Let's start with the questions that have 5 points for each. In question number 21, what does the object in the picture looks like when viewed from above? So here let's check at first. Here we have two blacks, then one gray, then one black, then two gray. So if we check here, two blacks, one gray, one black, and two gray. So this one is correct, and most of the questions, most of the answers here are correct, except E. Here we have two blacks, then two gray instead of one gray. So we can exclude E here. Now let's check this one. If we started from this point here, so we have one black, two gray, one black, gray, one black. So here we have one black, two gray, and then two black. So this one is not correct. In B we have one black, then one black, two gray, one black, and then gray, and then black. So this one seems to be correct. In C, if we started from here, we have one gray instead of black. So here C is not correct. In D, we have one black, then two gray, and then one black, then two gray. It must be here two gray. So this one is not correct. Here also we said not correct. So B is the correct answer. In question number 22, three small squares are drawn inside a large square as shown. What is the length of the line marked with a question mark? Okay, so we can here we have the side length of the square is 28. So and this distance is 22. So here we have 6. So the side length of this small square is 666. So and for here also we can also calculate the side length of this square here. So we have here for 15, and the total length is 28. So here we have 13, and here 13, 13, and 13. Now we know that all of this length here is also 28, and here we have 6 and 13. So here we will have 9. So here we will have 9, 9, and 9. So the distance here is equal to 28 minus 9, which is equal to 19, and E is the correct answer. In question number 23, 9 tokens are black on one side and white on the other. Initially, 4 tokens have the black side upward. In each turn, you have to flip 3 tokens, not necessarily adjacent. What is the least number of turns you need to have all tokens showing the same color? Okay, so we can, for example, flip these 3 coins here. So after the first flip, these two will remain black, and this two will be converted to white, and this one will be converted to black, and these will remain white. And after that, we can use another turn to flip these 3, this one and this one and this one, because in the question they are telling us so not necessarily adjacent, so we can flip these. And now in the after the second flip we will have here white, 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 and white. All of them are white. So after 2 turns, and B is the correct answer. In question number 24, which of the following options will definitely balance the third scale? So here, if we add these two and these two, let's see what we will have. So I will put this one here and this one here, and I will put these two circles and one square. Now we remove this one and we have this scale, so I can simplify and reduce the similar shapes from each side. So I can remove this triangle with this triangle and one square with one square. So the remaining is one arrow and two squares, which is the required here. So it is equivalent to 3 circles and one triangle, and C is the correct answer. In question number 25, 10 people each order one scoop of ice cream. They ordered 4 scoops of vanilla and 3 scoops of chocolate and 2 scoops of lemon and 1 scoop of mango. They top the ice creams with 4 umbrellas, 3 cherries, and 2 wafers and 1 chocolate chip. They use one topping on each scoop such that no 2 ice creams are alike. Which of the following combination is not possible? Okay, so here we have 4 vanilla scoops. So we will use with them each one of these here. So we will use 1 biscuit and 1 wafer, 1 chocolate and 1 wafer, and 1 cherry and 1 umbrella. So we cannot select vanilla with umbrella here. This one is not correct, and vanilla with chocolate chip is not correct. Now let's see the. Now we have 3 scoops of chocolate, so we will use 1 wafer, 1 cherry, and 1 umbrella. So chocolate with a cherry is not correct. Now we have also 2 scoops of lemon, so we will use 1 cherry and 1 umbrella. So lemon with a wafer is not correct here. It can be existed, so this one is the correct answer, and we should select D. In question number 26, we call a 3-digit number nice if its middle digit is greater than the sum of its first and last digit. What is the largest possible number of consecutive nice 3-digit numbers? So, for example, 152 is a nice number because here, if we sum 1 and 2, is 3 less than 5, the middle number. So, this number is a nice number. So, for example, if we try consecutive numbers, 3-digit consecutive numbers, for example, 151, this one is a nice number because 1 plus 1 is 2 less than 5, and 152, 153, and 154. Is 154 a nice number? No, because 1 plus 4 is equal to 5, not less than 5. So, for example, here just we have 1, 2, 3, 4, 4 nice numbers, consecutive nice numbers. So we need the largest possible number of consecutive 3 digits. So I should make the number in the middle as big as possible, the digit. So I will select 9. Here in the 100 place, I will select 1 because I cannot put 0. And here I will put 0 to start with the smallest numbers. Now this is the first one. 1 plus 0 is 1 less than 9. 1 plus 192, 193, 194, 195, 196, 197. Now 198 is not a nice number because 1 plus 8 is 9 less than equal to 9, not less than 9. So this one is not consecutive. Well, not a nice number. So here we have 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7. Sorry, I forgot to write 191. So we have 8 nice consecutive nice numbers, and D is the correct answer. In question number 27, Ahmed has to play 15 games in chess tournament. At some point during the tournament, he has won half of the games he has played, and he has lost 1/3 of the games he has played, and 2 have ended in a draw. How many games has Ahmed still to play? Okay, so here we have 2 ratios and one number, which is 2, ended with in a draw. So here, if we sum 1 over 2, which is the ratio of the number of the games that he win at them, plus 1 over 3, number of games he lost, this will be equal to 5 over 6. So the number of the games that ended with in a draw is 1 over 6, the complement of 5 over 6. So 1 over 6 is equal, but here we have 2 games, so we should multiply here by 2. So we will have 2 over 12. So now we know that the total number of games that he played till now is 12. So now 12, half of them, the games he wanted them, so we have 6 here, and the third of the games he lost, so here we have 4, and 2 ended in a draw, so 2. And if we sum these games, we will obtain 12, so that's correct. And we know in total he will play 15 games, so the number of the games that he still to play, Ahmed still to play is 3, and B is the correct answer. In question number 28, Badr has a square piece of paper divided into 9 cells. He folds the paper as shown, overlapping horizontally and then vertically so that the gray square ends on top. Badr wants to write the numbers from 1 to 9 into the cells so that once the paper is folded, the numbers would be increasing in order with numbers 1 on the top layer. What's the number should be written instead of A, B, and C? Here Badr wants to order them in an increasing order, so here we will have 1, 2, 3, and here 4, 5, 6, and here 7, 8, 9. So we will write 1, 2, 3, and then here, for example, 4. We'll start here from 4, 5, and 6, and here 7, 8, and 9. So as we can notice, here we have 1, 2, 3, and then this one is folded. So here we will have 4 after the 3, and then 4, 5, 6, and then this one will be folded, and we will have 7, 8, 9. So the numbers instead of A and C and B is should be 6 and 8 and 4. A is 6, B is 4, and C is 8. So A is the correct answer. In question number 29, David builds a pyramid with balls. The square's base consists of 3 by 3 balls. The middle layer has 2 by 2 balls, and there is one ball at the top. There is glue at each contact point between two balls. How many glue points are there? Okay, so let's look at the contact points horizontally, then vertically. So at the first layer, here the base, we have 3 by 3. So here we have one connection point, and here also contact point. So 2, 3, 4, 5, 6, 7, 8, and here 9, 10, 11, and 12. So we have 12. In the second layer, we have 4 balls. So here we have 1, 2, 3, 4. So we have 4. In the third layer, we don't have any connection because we just have one ball. So till now we have 16 horizontally plus. Now let's see vertically. As we can see here in the second layer, each one of the balls has a connection with 4 balls. Like for example, here if we put a ball here, so this ball has 4 connection contact points with these 4 balls under it. So 4 multiplied by 4 is 16, and we have this ball at the top has a connection with the second layer, so it has 4 connection because we have 4 balls under it. So this is the total number of contact points. Now here, if we sum all of these numbers, we'll obtain 36, and E is the correct answer. In question number 30, the last question, the figure shows a map of some islands and how they are connected by bridges. A postman has to visit each island exactly once. He starts on the island marked start and would like to finish on the island marked finish. He has just reached the green island in the center of the map. In which direction should he move to be able to complete his route? Okay, so first of all, let's assume he will start from here. So let's assume he go from this direction. So by going from this direction, it's so hard to go through all the islands after that. If you If we reach to this island and he follow this path here, so he will reach the finish island without reaching the other island. So let's try another path. So here, if we started from here and continue from upward, so and then like this to the right, and then here like this and like this here in this road, and then to the green island, then continue right, and now to the south, to the west, and to the south again, and then to the north. So this one is a correct path. So while he will reach to this green island marked green, so he will go by he will reach the finish by going east. So B is the correct answer. And by solving this question, we have reached the end of this exam. See you in the next videos.